Okay, before we begin, I just would like to confirm that you guys can hear me. Please can you just type in chat and confirm that you can hear me? Okay, perfect. Okay, so thank you everyone. Okay, Assalamu alaikum and hello to everyone. Welcome to the inaugural lesson for grade 12 maths tuition from Inspired Teens. I'm going to be a tutor for the rest of the year. My name is Abdullah Ali. And today we'll be starting with sequences and series. Okay. If you guys have any questions, you can make use of the chat feature as well as Q&A. Okay. Yeah, you may use those two. I already have a question. Yes, so the PDF that so with regards to notes, you may choose to make your own notes. And you also, the PDF and the notes that I will be doing with you guys will be available in the group to you guys after the lesson. Okay, by the latest, the evening of the lesson. Okay, yeah, anything else before we begin? Yeah, just make sure use of the Q&A, the YouTube chat, the Zoom chat, if you guys do have any questions, and I'll try my best to attend to them. Okay, I do see all questions, so if I don't answer your question immediately, I will eventually get to it. Okay, and yeah, there'll be a few things that we will discuss at the end. Okay, cool. Matrix, right? This is the series class. Okay, sequences and series. We're going to start off with the basics. We're going to do arithmetic, quadratic, and then geometric. Okay, as well as the series, which is the sum version of the sequences. Okay. So let us start off with arithmetic sequence. So arithmetic sequence is a sequence formed by adding a common difference to the previous term. Okay, so okay, before we get there, what we do is we have the first term, which we refer to as A. And when we add a common difference, so common means the same difference each time. So when we add a common difference, so if we add D to the first term, so let's work with actual values. Let's just say we have 5 and we add 3. That forms our first term. We can call it, it will be 8. Then we take 8 and we add 3 again. That gives us 11. That's term 2. Then for term 3, we can take 11 and add 3 again. So that is what they mean by a common difference. Okay, the difference can be a minus, it can be an addition. Okay, so 11 plus 3, that gives us 14. So term 1, term 2, term 3, 8, 11, 14, that is now forming an arithmetic sequence. Okay, it's a sequence formed by adding a common difference to the previous term. So adding the same thing each time or subtracting the same thing each time. So in that case, actually, this is really important for arithmetic. The difference, okay, is equal to the second term minus the first term. Okay, but as well as the third term minus the second term. So it's basically that the difference is equal to n plus 1 minus n. Okay, let's get to these first, then we can discuss n. But essentially, the difference is always going to be equal to the next term minus the previous term. So T2 minus T1, T3 minus T2, T56 minus T50. Let's write it here. It could be also equal to T56 minus T55. Okay, that would give you the common difference as well. All right. So basically, every single term, okay, previous and following term has that common difference. Let's talk about these variables. We have firstly Tn, which represents the general term. So you can see here that I have written T1. This means that it's term 1, the first term. The value of the first term is 8. Okay. N is the number of the term. Okay. So in this, for example, the first term's value is 8, but the n here is 1 because it's the first term of the sequence. The n here is 2 because it's the second term of the sequence. The n here is 3 because it's the third term of the sequence. Okay. However, the value of term 1 is 8, the value of term 2 is 11, and the value of term 3 is 14. Okay. So in this case here, we could say T1, term 1 is equal to 8. Here we could say term 2 is equal to 11. Here we could say term 3 is equal to 14. Okay, so yes, and remember this little number is actually n. That's why we have Tn. Okay, because this n represents again the number of the term. That's important to understand. Number of the term. So Tn, okay, only pure, no mathlet. Yes, no mathlet. I'm not sure as yet. We might have classes for mathlet. Not yet in the plans, but yes, this is pure maths only. Okay, for now. Okay, so n again is the number of the term. So when we say Tn and we describe it as the general term, remember n could be anything. N could be 1, 2, 3, 4, 5, whichever term you in the series you're talking about. So when we talk in a general sense, we say Tn. Okay, that's equal to the general term. Okay, sorry about that confusion. Then we have n, which is again the number of the term. A is T1. So A is the first term. The first term we call A, okay, which is also just T1. And then D, as we discussed previously, is the first difference. Okay, it could be first difference. In the case of arithmetic, it's actually the common difference because you only get one difference. It doesn't change. Okay, so arithmetic sequence, right? We discussed a few things so far, all the variables. So Tn, general term, n, number of term, A, first term, and D, the common difference. Okay, right. Let's move over to the general formula. So this general formula is given in your formula sheet. This is the general formula that we use in arithmetic. So the general formula says Tn is equal to A plus n minus 1 times D. Okay. Contact me after, Mr. Ivo, and we can chat then. Okay. So Tn is equal to A plus n minus 1 times D. So remember we said Tn is the general term. Now, if I had to say T5, okay, in this specific pattern, I'm going to add 3. I have 17 and I add 3 again, I get 20. So this is actually T5 in this case, right? So if I had to say T5, that would be equal to, what did we say? 20. Okay. When you say Tn, you are basically saying any term in the pattern, because remember, you're still expressing n as a variable, meaning it could be 1, then this would change. It could be 2, then that would change. It could be 3, then that would change. That's why we're saying n. We represented it in terms of a variable in a general sense to say any value in that term. So any value in this sequence can be calculated utilizing this formula, taking the first value, remember A is the first term, and adding it to the number of terms minus 1 multiplied by the difference, the common difference in the case of arithmetic. Okay, so remember this is given in the formula sheet, so you can work with this formula. Okay, so steps to determine the nth term. First, you find the constant difference, then you use T1 as A. Okay, so basically these are the unknown variables in that, right, which we're going to work through now. Okay, so that's our basics, our explanation. We've been through the formula. Again, the sum formulas, which is the series of arithmetic that we will go through later. Let's look at the first example. We have a pattern. They say given -6, -2, 2, 6, 10, 110. So when we have something like this, that's obviously the first term. Then we have comma, dot, dot, dot. That just represents all the terms in between. There's numerous terms in between. Then we have 110. And after 110, there's no semicolon anymore. There's a full stop, which means the term. That's actually the last term of the sequence. Okay. So they say determine the general term. They want Tn. So they want a general formula for this sequence. So let's go through the steps one more time. It says first calculate the constant difference. Then you actually have A. Okay, you have A because if you have the first term in the pattern, you have A. So in that case, we first have to determine the common difference. Remember, common difference could be equal to T2 minus T1, or it could be equal to T3 minus T2, or it could be equal to T59 minus T58, anything, as long as it's two consecutive terms, the bigger one first. So in this case, I'm simply going to use T2 and T1. So I'm going to say that to calculate my difference here, I'm going to say minus 2 minus 6. Okay, put that in your calculator. You're going to get positive 4, I believe, because it becomes negative 2 plus 6. Okay, so the common difference is positive 4. So let's just write out Tn first in a general sense. The general formula that you get from your formula sheet is a plus n minus 1 times the difference. So let's work here with a. So just one more time, Tn is equal to a plus n minus 1 times the difference. Now, because I have the difference, okay, I can substitute its value. So now I have Tn is equal to a n minus 1 times the difference, which is 4. So times 4. I also have a, which is the first term, minus 6. So I can substitute that value directly into the formula as minus 6. And now I can simplify. So I'm going to get Tn is equal to negative 6 plus. This is distributive law. The 4 after the bracket is the same as having the 4 before the bracket. So this here is essentially like writing the same thing, just rearranged. Okay, so don't let that confuse you. So just like how you would distribute this 4, you would distribute that 4 as well, keeping in mind this sign is for that 4. Okay, or it's for the whole term in general. But in this case, how you would say positive 4, you distribute it into the bracket. Here, you would also say positive 4, distribute it into the bracket. So when we do that, we can simplify to positive 4n minus 4. We simplify like terms. We get Tn is equal to 4n. I write my variable term first, minus 10. Okay, I hope that makes sense, right? So we have the general term. So you might be thinking, why do we have a variable? That's because the general term is written in terms of a variable. Okay, remember, we are calculating Tn, meaning the term value for the nth term of the sequence. So n could be 5, n could be 6, but this formula is essentially saying that no matter which term in the sequence you want to calculate, you can utilize this formula. So if you want to calculate the 60th term in the sequence, you would simply substitute n as 60. So the 60th term in this specific sequence is 230 after the maths. Okay, so yeah, this general term Tn is to calculate the value of any term in the sequence. Okay, let's do C first, and then we can go back to B. They say the value of the 14th term. Now that we have the general term, we can simply calculate the 14th term by substituting it into the general term that we calculated. So 14 minus 10. When you do the calculation, you get 46. Okay. Yeah, I'm going to go back to B. I just wanted to do C first because it's easier. Okay, let's talk about B. Which term in the sequence exceeds 84? Okay, so before we do this one, let's actually do another one that before we just the word exceeds is slightly complicated. Let's just say which term in the sequence is equal to 70. Okay. Let's read the wording carefully. They are asking which term in the sequence is equal to 70. So the value of the term is being given, not the number of the term. They're not saying that this is T70. They're not saying that. They are asking for n, because they're asking which term has the value of 70. So they are asking for n, and they're actually giving us the value of 70. So if we have to write out our general formula, it is Tn is equal to 4n minus 10. Okay, so I'm not going to substitute 70 for n. I want to work out n. I actually equate this whole thing to 70. The reason for that is because the value of that term is 70. So I need to calculate which term is that in the sequence. So I will equate the general term to 70 to get me a value for n. So I take 10 over, I get 80 is equal to 4n, and I get n is equal to 20. So the 20th term in this sequence, so T20, is equal to 70. Okay, let's move all of this without that, if possible. Just move it down. Let's call this, sorry, I should call this C. Let's call this, I don't know what's between A and B. 8.5. Doesn't make sense, but it's fine. Let's do B now. They ask which term exceeds 84. So the word exceeds means which term is greater than 84. So what we do in that case is they are asking the value for n, okay, because they are saying which term in the sequence exceeds 84, okay? So they're not asking what is the value of this term or the value of that term. They're asking which term in the sequence exceeds 84. So which term in the sequence is actually bigger than 84? So in that case, what we would do is we take our general formula, Tn, which is equal to 4n minus 10. We're going to say 4n minus 10. Okay, remember 4n minus 10 is actually the value of the term, but expressed in terms of n. And we're going to ask ourselves which one of those, which n is actually greater than 84. So we solve with an inequality. So we say 4n is greater than 94. And we say n is greater than, when we do the calculation, 94 divided by 4 is actually 23.5. Okay, so obviously 23.5 is not an actual term. This is basically telling us that the 23.5th term is actually 84. So which term would be greater than 84? That would be the 24th term. Okay, because again, 23rd term, we can even do the calculation. T23, if we calculate T23, 4 times 23 minus 10, that gives us 82. 24th term, if we do the calculation, that gives us 86. So that's why 84 is actually the middle, somewhere in between here. Okay, that's where we got our T23.5. That's why it's literally the middle of 23 and 24. Okay, but that's not a valid term. Our term number has to be a whole number. Okay, so in that case, again, let's read the question. It says, which term in the sequence exceeds 84? 84 is clearly between 23 and 24. The way we calculate it mathematically is we say that the general term greater than 84, and it says, oh, n has to be greater than 23.5 to be greater than 84. So in order for the first n, the first term number that's greater than 23 is 24. So which term exceeds 84? 24th term. Okay, let's look at D. How many terms are there in the sequence? Okay, I have a question I'll get to now. Do we not swap the sign over? Is that only when dividing? If you're talking about the inequality sign, the only time you swap the inequality sign over is when you divide or multiply by a negative. Not just any dividing, not just any multiplication. When you divide or multiply by a negative specifically, that's when you'll swap it around like that. Okay, in this case, we're not dividing by a negative, so we don't do that. Okay, let's look at the last question one more time. How many terms there are in the sequence? English. How many terms are there in the sequence? Okay, so basically they're asking the total number of terms in the entire sequence. Now, normally, you wouldn't be able to calculate this unless you have the actual value of the last term. So let's look at it, right? this is T1, this is T2, this is T3, this is T4, this is T5, and so on and so forth. And finally, the last one, let's just say there's 100 terms in the sequence, for example, this would be T100. Okay, but because we don't know how many there are in the sequence, we can just call it Tn. Okay, but the term number of 110 is the final n, firstly. Secondly, that n will actually tell us how many terms are there in the sequence. So the n of the last term, the term number of the last term, tells us how many terms there are in the sequence. If we put it simply, if I have a term 5, 10, 15, 20, 25, full stop. This is T1, T2, T3, T4, T5. The last term in the sequence is the fifth term. How many terms are there in the sequence? 5 terms. Okay, so basically we have to calculate the Tn for the final term. So in that case, I'm going to say, firstly, I'm going to write out Tn is equal to 4n minus 10. And now I need to calculate n, and I know the value of that term, Tn. I know that it's 110. So I'm going to equate that to 110. 110 is equal to 4n minus 10. I take 10 over, I get 120. 4n, n is equal to 30 when I do the calculation. So therefore, there are 30 terms in the sequence. How did I know that? I basically calculated which term is the last term in the sequence, and that told me the total amount of terms in the entire sequence. Okay, how did we get 24 in the previous question? So one more time, the question was which term in the sequence exceeds 84? So remember, 84 is the value of the term, and they are asking which term is it. So is it term 1? Is it the second term? Is it the third term? Is it the fourth term? So that's always to do with n. So we need to calculate n. So what we did was we took our general formula and we said 4n minus 10 greater than 84. Okay, and then when we simplified the calculation, we got 23.5. So the term that exceeds 84 is the term that's greater than 23.5. The first term that's greater than 23.5 is the 24th term. Okay, so that's how we got 24. Okay. So that's a basic example with all the basic questions, right? Those are common in the exam, actually, right? Now we're going to move on to a slightly more complicated example of arithmetic as well. Okay. So let's look at this example, example 2. It says m, 2m plus 2 and 5m plus 3 are 3 consecutive terms of an arithmetic sequence. Now, don't get confused just because they added variables. So look at it carefully, right? M is term 1. So I actually have the value of a. The value of a is m. Okay, we can pretend that m is a number. We can treat m as a number. Then I have 2m plus 2. Now, this is not T2 and T3. The entire thing in itself is T2. 2m plus 2. The entire thing in itself is T2, right? Then we have 5m plus 3. That's T3. Okay, these are 3 consecutive terms, so that's really important. Okay, so there are 3 consecutive terms in an arithmetic, so maybe it's not 100% correct to say that they T1, T2, and T3, because, okay, we know that definitely they are consecutive. Remember, consecutive means one after the other. So they could be T1, T2, T3. They could also be randomly T56, T57, T58. They could be T5, T6, T7, okay? They don't specify in this question. I did this question, so I know that they are actually T1, T2, and T3. They don't specify specifically, but it doesn't. Is it 30? In the chat, I think you're talking about the final answer. Yes, it is actually 30. Okay, but it doesn't really matter. You can still get the calculation, but I'm just making sure that you're careful with the words. Okay, it's 3 consecutive. However, they don't specify that it's actually the first 3 terms. Okay, determine the value of m. Okay, I'll confirm that for you in a second, right? So now they want us to determine the value of n. Whenever, this is for arithmetic, this is for geometric, this is for quadratic. Whenever you have terms with variables, remember what are variables? Variables are unknowns, okay, our letters, our favorite letters, okay? Whenever you have these sequence and series number pattern questions with variables, the first thing you want to think of is your common difference, okay? That formula for your common difference, D is equal to T2 minus T1, which is also equal to T3 minus T2. Because this is what you're going to use to create an equation to solve for M. Okay, you'll see in geometric, we're going to use a similar concept where we're equating the differences because it is a common difference. Common means what? Common means that they are equal. So if we can get a value for T2 minus T1 and a value for T3 minus T2 and equate them, we'll be able to solve for M. We can, and the reason we can equate them because it's a common difference, they are equal. So let's try that out here. Okay, so for A, we're going to use this guy. The difference, which is going to be equal to T2 minus T1 and T3 minus T2. So let's do that. Okay, remember there's variables and there's a negative, so I'm going to be using brackets. So T2 minus T1, that's 2M plus 2 minus M. T3 minus T2, that's 5M plus 3 minus open brackets 2M plus 2. Because this expression has a plus or a minus and we are subtracting it, we have to use brackets because this negative is going to distribute inside. Okay, in maths in general, whenever you're substituting something, you want to use brackets. If you're going to forget your brackets and there's a negative, it's not going to distribute and it's going to change your answer. Okay, so let's simplify. I'm going to say 2M minus M, that's M. So on the left hand side, I'm left with M plus 2. On the right hand side, I need to open up my bracket. So I'm going to keep this as 5M plus 3 becomes minus 2M minus 2. I distribute the negative. Negative 1, essentially, remember the invisible 1, times positive 2M. Added it wrong. Oh, okay. Negative 2M and negative 2. Right. So I'm still left with M plus 2 there. Now I'm going to simplify like terms on the right hand side. 5M, negative 2M, positive 3, negative 2. When I do that, I get 5M minus 2M, that's 3M. How did I get that? The yellow. Okay. Plus 3 minus 2 is plus 1. How did I get that? The blue. Now this is the basic like grade 8 equations where I have an unknown, a singular unknown. So I'm going to try and isolate the variable, leave the variable on one side, leave the other values on the other side, solve for the variable. So I'm going to say M, I'm going to take this guy over. It's positive 3M on the right. So it's going to become negative 3M on the left. This is going to, I'm left with 1. I take over the 2, it becomes negative 2. So when I do this calculation, remember there's an invisible 1 there. So it's 1M minus 3M, that's negative 2M is equal to negative 1 because 1 minus 2 is negative 1. When I take this guy over, the negative 2 over, it becomes negative 1 over negative 2. M is therefore equal to a half. Okay, so please remember, whenever you're working with variables, okay, especially in arithmetic, geometric, and in quadratic, your first reaction should be to try the difference, the common difference. In geometric, it's called the ratio. And in quadratic, we actually have two differences. Doesn't matter, we'll get to those, but to use the concept of the difference, and a difference minus the previous difference is equal to any difference minus its previous difference, meaning T2 minus T1 is equal to T3 minus T2, which is also equal to T55 minus T54, anything random. How many marks would you get for a question like this? Okay, it depends. The marks could be split, but generally I would say for this specific question, 3 to 4 marks. Okay, explain A one more time. Okay, I'm just going to go through it briefly. Okay, so we used the difference. Okay, again, we worked with variables and then we don't know the actual values of T1, T2, T3, but they want the value of M. So what we're going to do, because we have expressions for T1, T2, and T3, we're going to use the idea of having a common difference. So we said T2 minus T1 is equal to T3 minus T2. And we equated those two because it's a common difference, they're equal, and we solved for M because there's one unknown. Okay, now that we have the value of M, they say if the 12th term is 28, determine the sequence. Okay, let's not, okay, let's specify when they say determine the sequence. Determine the sequence means first 3 terms. If they had to ask for the general term, we would know that it would be Tn. Okay. M is not equal to 2. M is equal to a half. Okay, I went through it again. Just let me know if you still don't understand. YouTube chat. Okay, so yes, okay, so determine the sequence, first 3 terms. General term means Tn. Yeah, that's something that's important to know. Okay, so if they say determine the sequence, you're not giving Tn itself. Okay, so just to specify now, this question is a bit silly because they're giving us other information, even though we don't technically need it to determine the sequence, because we have M, so we can simply substitute M in there and we can get the first 3 terms. Nevertheless, let's just do it. I'll get to your question in a second. If the 12th term is 28, determine the sequence. So they're saying the 12th term is 28. So T12 essentially is equal to 28. Determine the sequence. Can we solve for M in this case? Okay, I see the issue, yeah. Okay. So basically, this we don't need it for this question. This is needed for when they say determine the general term, which we're going to do next. But what we can do first is we can determine the sequence. Because we have the value of M, we can determine the sequence. So T1 is M, so T1 is half. Okay. Then we have T2, which is 2 into M plus 2. So 2 into a half plus 2. This is T2. Then we have T3, which is 5 into a half plus 3. Okay, so we have a half. We have 2 times half is 1 plus 2 is 3. And we have 5.5 plus 3. We can just call that 11/2. We'll leave it as a fraction. Okay, so now we have determined the sequence, the first 3 terms of the sequence. Okay, furthermore, they want us to determine the general term. Okay, they say if the 12th term is 28, again, we don't really need to use that. Okay, it's fine. Let's not use that. Yeah, that was unnecessary. It was like if they had more unknowns, then that would have been necessary. But because we have the series, the sequence, then we can simply use the sequence to determine Tn. Okay, why? Because remember the steps to determining Tn, you need A and you need D. You need A, the first term, and you need the difference, both of which we have. A is 1/2. D we can determine by saying T 2 minus T1. That's the difference. So 3 minus a half, essentially, we get 2,5 or 5/2. So difference is 5/2. Now we can determine Tn. So we're going to say Tn is equal to, this is the general term, A into n minus 1 times the difference. Tn is equal to 1/2 plus n minus 1 times 5/2. Okay, when we simplify this, remember distributive law, you can use your calculator to determine 5/2 times minus 1, but it's minus 5/2 either way. When we simplify everything, we get Tn is equal to 5/2n minus 2. Okay, thank you for assisting. Well, they always indicate if it's arithmetic. If not, how do we know it's arithmetic? The next person answered it well. They won't always indicate if it's arithmetic, but yes, it will have a common difference. A lot of the times they do, Okay, but if they don't, then you can use your understanding that it has a common difference. So just a common difference, one common difference that you can, then you can determine that it is arithmetic. Why did we take T1 as half? Because T1, like someone said in the chat, is M, and the value of M is a half. We calculated it. Okay, I see what you're saying. Okay. I see what you're saying. That's where this came into play, but it's actually the first, second, and third term. So there's no need to make this one complicated, because I assume that it's T1, T2, and T3. Don't worry, in an examination setting, there's not going to be any sort of everything's going to be clear. Okay, but in this case, it is T1, T2, and T3. Those specific values are T1, T2, and T3. Okay. What is the difference between Tn and n? Is the difference 2.5? The difference between Tn and n, okay, Tn is the term for n, and n is the term number. Okay, so Tn is generally your value, whatever is the value of that term, and n is basically where it is in the pattern. Is it the 5th term? Is it the 6th term? Okay, so like for example, in a pattern like 2n minus 2, if I substitute 5 for n, I get 10 minus 2 is 8. In that case, I substituted 5 for n. So this is actually, I'm calculating the 5th term. So I could say T5 is equal to 8. Okay, or in this case, n, which is the 5th. Sorry, this is not true. I didn't mean to put an equal to sign. The difference between Tn and n. So in that case, Tn, that's actually equal to the long formula, but I'm just going to say Tn is equal to 8, or T5 is equal to 8 in that basic example. Okay, let's just get to a few more questions. N is equal to 12. If you use T3 minus T2 and the difference. Yes, so someone asked, can you use T3 minus T2? Yes, you can. To get D, you can use T3 minus T2. It's the same thing, okay, as T2 minus T1. If you say 11 over 2 minus 3, you get 5 over 2 as well. Okay. Okay. I'll try and get to a word problem example. Let's have a look at the next one and see if that's what you want me to solve. Okay, but yes, all right. So that's general term. That's when we have variables. Okay, let's try and finish this example because time is going pretty quick. Okay, example number 3. Find the arithmetic sequence if the 6th term is 10 and the 14th term is 58. Okay, let's just see in this chat. But we don't know it says the person, so do we still take it as it is? Can we use a plus a minus t equal question as t equals 2? Yes, most likely. A question like this could be asked in the test. Eli, could you please rephrase the question because I don't understand what you're asking? Okay, but example 2 is a very common question in a test. Okay. So you would need to know, and like I said, whenever these variables come into play, what you want to do is you want to your first instinct is that you should use your common difference. Okay, the understanding that the second term minus the first term is equal to the third term minus the second, or any terms in the sequence, provided that they are consecutive terms. You're taking the bigger one minus the smaller one. It's always going to be equal to, for example, T2 minus T1. Thank you so much, Lalitha, for explaining that. Okay, let's move on to the next one. Okay, this is a slightly more complex one. Okay, so in this case, we don't have the terms, like we don't have T1, T2, T3. Then the question is wrong. Why do you say that? Okay, we don't have T1, T2, and T3. We just have certain information. We have the information that the 6th term of this pattern is actually equal to 10, and the 14th term is 58. So what do we do in this case? Okay, we work with what we have. So essentially they're telling us here that the 6th term, so T6, is equal to 10. And here they're telling us that T14 is equal to 58. Okay, so in that case, right, what I should do is, because I know the general formula for Tn, I should express each of these in their own equation, okay, and work from there. So T14, for example, I can say that, so T14, remember, T14 is equal to 58. So when I equate it to this entire equation, I'm going to say that 58 is equal to, I don't know A, I don't know my first term. I know N, okay, because remember, I'm working with the information that T14 is equal to 58. So in this case, N, the term number that's equal to 58 is 14 minus 1 times D, which again is unknown. I don't know the common difference. I don't know any 3 consecutive terms. All I know is that T14 is equal to 58. Okay, so therefore the value of the term, I equate the entire general term to, not the general term with all variables. However, I do know one variable, which is N. Which term number am I working with here? I'm working with the 14th term that's going to give me the value of 58. So therefore, I say 58 is equal to A plus 14 minus 1 times D. I simplify this, I get 58 is equal to A plus 13D. I can do the same for this guy. I know that the 6th term is equal to 10. The value of the 6th term is equal to 10. So I say 10 is equal to A plus N. Which term is 10? The 6th term. So N is 6 minus 1 times the difference, which is unknown. Okay. Now you might notice something. We have 2 equations. Let's just simplify this one. Okay, we have 2 equations and 2 unknowns. In algebra, in maths, when you have one unknown, you could solve it using one equation. When you have 2 unknowns, you would need 2 equations to solve it. So in this case, I have 2 equations with 2 unknowns. This is simultaneous, correct? Yes, this is simultaneous. I'm going to do simultaneous. Before I get to simultaneous, could M be the common difference then? Okay, message deleted. Yes, correct, Eli. I understand what you're saying now that I read it. With the information given, that's exactly what you do. Okay, with the information given, I just didn't want to complicate it that much just because it was the second question we're doing. And when you actually do the calculation and you do it that way, that you are talking about, you will find out that T1 is actually M and T2 is that and T3 is that. Okay. What do you do in the difference between the terms example? Then there's an issue. Okay. T1 minus T2, T2 minus T1 has to be equal to T3 minus T2 in order for it to be an arithmetic pattern. So either it's not an arithmetic pattern or you have an error somewhere. Okay. It isn't T3 is equal. 5.5 and 3, the difference between them is 2.5, not a half. Just check that again and let me know. Okay, so let's continue with simultaneous quickly. All right, let's finish up the simultaneous. So yes, we have simultaneous. So there's multiple ways of solving simultaneous. I'm going to choose to do substitution. You may do addition, or there's many different ways, right? I'm just going to choose to do substitution. That's the most common and the easiest to use. So substitution, we isolate one of the variables. So let's leave A alone in this case. Leaving A alone, okay, I'm still keeping it on that side. I'm actually taking the 13 over, but I'm just flipping the way I write it. So I'm going to say A is equal to 13D. I take 58 over 13D minus 58. Okay, so when we isolate A in that case, we get 13D minus 58. So now I have A expressed in terms of D. So now wherever I have A here, I can put it there. And because I am substituting A in this case with something expressed in terms of D, I'm getting rid of the double variable, and I'm just going to be left with D. So now I have 10 is equal to 13D minus 58. I'm substituting whatever's here, because that's A. A is equal to 13D minus 58. So instead of writing A, I can just write 13D minus 58. Then I have it expressed only in terms of D. Now I have one variable, one equation, I solve. So I'm going to bring okay, let's just write it out. Okay, I'm going to leave the D on this side, the variable D. I'm going to take the negative 58 over as positive 58. So this becomes 68 is equal to 13 plus 5. That gives me 18D. Pretty sure. Am I correct? I don't know. Let's see. No, I don't think I'm correct. Where's the issue? Oh, you guys are right. I see. So yeah, sorry. So it should be A, and I take 13D over. Okay, cool. So it becomes 58 minus 13. Thank you so much. And that's why this is incorrect. Okay, so it becomes 58 minus 13D. So when I take it over, it actually becomes negative 48, right? 10 minus 58 is equal to 13, negative 13 plus 5. Okay, which gives us negative 8. Yeah, boy, that's now on the right track. We divide both sides by negative 8. So negative 48 divided by negative 8, and D is equal to 6. So someone put it in the chat and deleted it. I was wrong. You were right. Okay. So we get D is negative 6. Now that we solve for D in simultaneous, remember we call this equation 1. We call this equation 2. And then the one we rearranged, we call equation 3. Whenever you solve for one variable, it's always the easiest to substitute that known variable into the rearranged equation. So we have A into 58 minus 13, open bracket 6. And when you solve for it, you get A as negative 20, I'm pretty sure. So again, we're not done. We've just found D and we found A. They want us to find the arithmetic sequence, which we're going to solve for Tn. They want us to find the first three terms, but we simply just going to solve for Tn, okay, to get the general term. Okay. So remember the general term is Tn is equal to A plus n minus 1 times the difference. So here the general term is going to be equal to negative 20 plus n minus 1. So whenever we're solving for the general term, we don't need to substitute anything for n. Yes, okay, Moondrop, that would be easier, correct? There's different methods that people use for simultaneous. I chose to do substitution because most people actually use substitution. But if you want to isolate, like leave A alone each place and then equate that and then solve for D, you'd get the same answer. It's just a difference in methods of simultaneous. Okay, whatever method that you already use for simultaneous, you can use it and it would work. Okay, so yes, Tn is equal to negative 20, blah, blah, blah. So when we simplify this, we get 6n, let's just do it. Negative 20 plus 6n minus 6, I'm distributing the 6 into the bracket. Then I simplify like terms, I get 6n minus 26. Okay, don't panic, guys. I'm going to explain it one more time. Okay, I'll check how many marks will it be. I'll confirm with you in a bit. There should be at least 7 marks. I agree. I think it should be 15 marks. Okay, let's have a look at what we did. Let's read the question. Time is up, but we're going to finish in about 2 minutes. Okay, I just want to re-explain this one more time. Talk to you guys for like 1 second, and then we'll end it. Find the arithmetic sequence if the 6th term is 10 and the 14th term is 58. We don't know the first 3 terms. We don't know what the first term is. We don't know what the difference is, because in order to solve for Tn, generally our first 2 steps are solve for A, solve for D. We cannot directly solve for that. So therefore, we use what information we have and we utilize the equation to express that information. So remember, the equation is Tn is equal to a plus n minus 1 times d. All right. We know that the 14th term is 58. So all we did was we substituted whatever information we could into that formula. So 58 is the value of Tn. So 58. A we don't know, we left as A. It's the 14th term, so n is 14. And the difference we don't know, so we left it as d. Okay, then we get to the 6th term is 10. Same thing, same concept. We know the value of it is 10. We know it's the 6th term. We don't know A, we don't know D, so we left it as A and D. Then we wrote the two equations next to each other. We noticed that we have two equations, two unknowns here on this step here. So we could utilize simultaneous equations to solve for those variables. So you chose to use substitution. You could use many other ways. In this case, I left A alone and I substituted it in for this A. This went there and became that. And then I solved for D. Once I solved for D, I substituted it into the rearranged equation to solve for A. Once I solved for A, I substituted it in to get Tn. If you want to get term 1, 2, 3, you just substitute n as 1, 2, and 3, and you'll get your answers for the first 3 terms. So arithmetic sequence means first 3 terms, but you're calculating Tn just to confirm. Yes, that is correct. Okay. How many marks would this be? Let's just see. I have a similar question. It would be around a 4-mark question, 4 to 5 mark question. Okay. Okay. Look, so when will we do geometric? Okay. So with regards to geometric, right? Obviously, we just got arithmetic done today. We're still working on our time exactly per topic. So hopefully, let's say in the week, I'll be able to send you guys a timetable for the lessons and what topics we are going to be doing when. And we're going to start pushing. We're going to try our best to finish certain topics by a certain time. Okay. Obviously, we started late. So maybe some of you have a test in this week. Maybe some of you have already written a test. Okay. Our objective right now for the first term is to mainly prepare you guys for the first term exams, the end of first term exams. Okay. So we're going to also be working on a way to communicate with you guys. Just because we need like some information, when do some of you have your test starting, when do some of you have your examination starting and stuff like that. Okay. But yeah, with regards to covering the content in a certain amount of time, we're working on that. We're getting they're gonna work on a timetable to cover certain topics in certain time and whatever it is, right? But for now, okay, obviously it's our first lesson. We will get there. Okay, and we will we'll try our best to cover all the topics that most people need. Okay, and yeah, let's see. There's a few other things in the works. We will communicate to you guys as we as those things turn from words into action, and we'll take it from there. Okay, cool. But yeah, let me just see. Okay, no problem. You're welcome. What we do? You cleared in before the term 1 test. I'll have to confirm with you. I'm going to check the annual teaching plan for GDE to see if Euclidean is in there. If Euclidean is in there, yes, we're going to try our best to cover it before the first term. Yes, not later in the year. By next week, we're going to try and cover all of patterns. Okay. Is the question complete? Yes, the question is complete. When will we do geometric? Hopefully by next week. Would Euclidean be done? Let's hope so. Will we only have lessons on Saturday, or could we do it in the week? Okay, so yeah, that's what's in the works. Okay, it's our first month. It's a bit crazy. There's a lot of you, so there's stuff in the works, maybe to additional classes or whatever. I can't really confirm anything as yet, but again, we're starting off for now, and as things develop, we will communicate with you guys. Okay. Okay, perfect. Then hopefully we cover it. Okay, cool. I'm going to end it so that I can start my next class. Thank you guys so much for joining. I hope that it was beneficial. And yeah, hopefully it's a start of something really good. All the best to you guys. Good luck practicing what we've done today. I will send the PDFs by tonight. No problem. You guys are welcome. Jazakallah khair.